let's give us the ability to crouch. Unreal Engine has a built-in crouching mechanic, but I personally don't like it very much, and it's quite easy to make our own, so we're going to be doing that. So let's open our project settings, and in input, we want to create a crouch button, so we'll call it crouch, or crouch mapping, I should say, and I will parent it to left control. Now let's put the all this in BPC movement so we can keep it all in one Blueprint component. Just going to move this over this way. And we need two variables. So one will be crouch speed, and we'll make it a float of 200 by default. And we need one for crouch height. And this height is referencing our capsule component right here. And it's actually technically our half height, so we should probably rename it to be more accurate. But the default is 88, and if we were to decrease it, we become shorter. So let's change this back to 88. Compile and save. And we can actually change this name to crouch half height, so we are more accurate in our names. And we can change the default to 44. Do about half of what we are. Well, not about half, exactly half. So let's make a custom event, and we'll call it start crouch. And first thing we want to do is stop our stamina depletion, just in case we were sprinting and we go directly into a crouch from our sprint. So let's copy and paste this clear timer by function name, sprint timer. Oops. There we go. And then we want to set player max walk speed to our crouch speed. Compile and save. Now, one thing I want to mention that I made a small mistake in the last episode. I got Blueprint components mixed up with something else. We don't actually have to make these editable to see them in our L1 character. As you can see, like these four are not editable, but they still show up. So we can actually, you can turn those off if you want. The difference is whether they are public or private. So if you want ones not to be editable in here, kind of like the current stamina, we changed it to private. I'm going to do the same with the min stamina, change this to private. Compile and save. And now you can see we can only adjust our sprint speed, our walk speed, our max stamina, our crouch speed, and our crouch half height. So just to clear that up. So after we set our crouch speed, we need to shorten the height of our character's capsule. And we don't want to do this instantly, obviously, because that can look very janky and very snappy. So we're going to do it with a timeline. Timelines can't be created in Blueprint components, so as you can see, timeline. It's not there. So we have to do it in our character. So let's go to the event graph, and we have to make a custom event for this. So right click, custom event, and we'll call this shorten player capsule. And let's create a timeline. And we will call this capsule TL. And open it up. And first thing we want to do is set the length. So how long is it going to take your character to crouch? I will make mine take half a second. And let's make a float track. And we will call this alpha. We already made a timeline before, if you remember, for our doors. So should be slightly more familiar with what we're doing. This alpha channel will go from 0 to 1. And we will use a lerp node to make these whatever values we want. So let's create two keys, make the first one time 0 and value 0. The second one, the time, will be our length, which is 0.5, and the value will be 1. We can click these two icons right here to fit this, and we can select both, right click, and choose auto, so it's a bit smoother. Back in our event graph, we can plug this into play, and then we want to get our capsule component, and we want to set its half height, set capsule half height. Plug that into our update, and we get our lerp node, and our alpha will go into the alpha. So A is whatever your current capsule is. Ours is 88. Set that as 88. You can make that a variable if you'd like. And B will come from our BPC movement. So BPC movement, and we'll get crouch half height is what we called it, and plug that into B. Lastly, we want to create another custom event, and we'll call this lengthen player capsule for standing back up, and we will plug this into reverse. Compile and save. So back in BPC movement, we will have to get our player ref, and since this is a reference to character and not our L1 character specifically, we'll have to cast to the L1 character with this as the object. And we can right click on it and convert it to a pure cast. We don't need the execution nodes. And then as the L1 character, we just can call shortened player capsule. Alright, let's make a custom event. We'll call this end crouch. And we just want to set our player max walk speed to our walk speed. And then we just want to get our cast, and we want to call lengthen player capsule. Lastly, we will need a boolean, and we were going to call this is crouching. Set that to a bool, and we can set is crouching to true at the end of start crouch, and set it to false at the end of end crouch. Compile and save. And then in L1 character, we have to create an input for what we made at the beginning, which is our crouch input. We set ours to left control, and on pressed, we want to get our BPC movement, and we want to call start crouch, and we want to call end crouch, and then we want to get is crouching, and we will ask if we are crouching, and if we are, we want to end crouch, and if we're not, we want to start crouching, just so we can toggle between them. So compile and save. Before we test, I'm going to set our crouch speed to 100 to make a more discernible difference, and we can test it out. So let's hit play, walking around, and then we hit left control, and the timeline shortens our player capsule. Now when we walk around, we're much slower. Hit left control again, and we're at our regular speed. Now we have a small bug, and that is if we crouch and then we start sprinting, we just start sprinting while we're crouched, and we don't want to be able to do that. So let's go into BPC movement. So to fix this, we can just go into our start sprint, and on our start sprint, we have to make this a second branch instead of just adding on to the and I'll show you why. So let's create another branch, and we're asking if we're crouching, and if we're not, we can just go into the regular, but if we are, we want to call end crouch, and then we want to continue. So if we hit sprint while we're crouching, they will stop crouching and continue on to the sprint. So it won't just disable sprinting completely. For stop sprint, we want to add a branch and ask if crouching is false, or you could get a not boolean and plug it in like that. So if we are not crouching, that's true. And the reason we have to add it to stop sprint as well is because if we are crouching and we hit and we press down left shift, which calls start sprint, let's pretend for a second that this doesn't do anything. So it doesn't let us sprint, and then we were to release it, then it would set our speed back to our walk speed. So we would have our walk speed, but continue to crouch. So we can plug that back into the true, and we should be bug free. So let's hit play. We can walk around normal, we can sprint around normal, and if we hit crouch, and I start sprinting, he uncrouches and we are sprinting. And if I start sprinting and I hit crouch, he goes right into crouching. Then we hit sprint, stops crouching, and it gets back up. Great. It all seems to work very well. All right. That should be it for our crouching, and I'll see you in the next episode. Let's create a head bob for our character when we are moving. So let's go into Blueprints and create a new folder. That's what we called Camera Shakes, because we're going to be doing it with a camera shake. Now before we get started, I should advise you that you should know when to use head bobs and when not to. I personally think in quite a lot of games it's a good idea not to use head bobs for your world. In certain horror games, though, I feel like that is a good exception, but it all depends on your story. A head bob will definitely make your world seem more like it's being occupied by a player instead of it being virtual. But at the same time, head bobs can distract from mechanics in the game, specifically if you're trying to be exact. Say like in a first-person shooter, I think you have to be very careful with head bobs, and if you do use them correctly, because like for example, head bobs can make aiming fairly difficult, but a horror game can be a good exception. It all depends what kind of style and what kind of pacing you want your game to have. With that being said, let's get started. So let's go into Camera Shakes, and let's create a camera shake. So go to Blueprint class, down here, search Camera Shake. We choose Camera Shake right there. And we'll call this CS for Camera Shake. Head bob walk. Open that up. Now in here on the right, we just want to open these up real quick. We want to check single instance for camera shake here. We can do that first. And oscillation duration is going to be 0.2. Blend in time and blend out time can stay as default. In our rotation oscillation, open up our pitch. Amplitude is going to be 0.3 and frequency 12. For yaw, we're going to do amplitude 0.3 and frequency 6. For roll, we're going to do amplitude 0.2 and frequency 3. And close rotation. In location, we're only going to mess with the Z, and that'll be 0.6 and 12. And we can close that. And that is everything we're going to do for our walking camera shake. A camera shake legitimately is just messing with how you want your camera to rotate and locate, and just messing with the values how you see fit. These are values I like, and these are values I think look good. So let's duplicate this, and we'll call it run instead of walk. And we can open it up. And there's a few settings, and there's a few settings we need to change. So in pitch for rotation oscillation, this is going to be 0.5 and 17. Yaw is going to be 0.5 and 8. Roll is going to be 0.25 and 5. And for our location, Z, I'm just going to change this to 2 and 17. Everything else can stay the same. We've still checked single instance. Compile and save. And we can close both of them. So let's go into our L1 character. And we're going to make a function. I'm going to call it headBob. In our function, we have to ask if our velocity is greater than our walk speed and we are not falling. So, similar to what we did in BPC movement, we can actually copy and paste it if we'd like. We can get our velocity and vector length. And we have to ask if this is greater than our walk speed. So we get our BPC movement and we get our walk speed. Create a branch. Oh. We have to add a AND Boolean to this, because we also have to make sure our head doesn't bob while we're falling. So first we're just checking to see if we're sprinting, essentially. And we also have to make sure this velocity is coming from our movement on the ground and not from falling through the air. So we just have to get our character movement, get is falling, and get a not Boolean. And my apologies, this is supposed to be a greater than or equal to, not a greater than. So if we're checking if we are going greater than or equal to our walk speed, and if we are, we then have to ask if we're going greater than or equal to our sprint speed. So we're basically just figuring out if we're walking or if we're sprinting or if we're doing neither. So let's get this vector length and ask greater than or equal to, and we can get our BPC movement again, get our sprint speed, and for safety measures we can ask if we are not falling again. Is falling, and get a not Boolean. So if this is true, we're sprinting, and we need to get the player controller and client play camera shake. Ball off to true, and the shake will be our sprint or our run. And we can duplicate this, because if this is false, it means we are walking, and we will set this to walk, and plug in our controller for target. Lastly, to make it not janky and a bit smoother, for this scale, which is a value of 0 to 1, instead of just having it at 1, we're going to copy this and move these over just a bit, just give us some more room. And we're going to be using what's called a map range clamped. So we'll search for map range clamped, and first we have a value, and then we have 4 floats. And one's the in range A and B, and then the out range A and B. So for in range A and B, it's going to be going from 0 to our max walk speed from a character movement. So for example's sake, let's say this is 400. Now if our outrange A is 0 and our outrange B is 1, this will convert the range of 0 to 400 to 0 and 1. So 200 would output a value of 0.5, and 100 would output a value of 25, 400 would output 1, 0 would output 0. So we can plug in this return value into the scales and compile and save. Back in our event graph, we have to find our move forward and move right, because after both of these, we will be calling our head bob functions. So we can compile and save, and we can now test it out. So when we're staying completely still, so is our camera. And when we walk forward, we have this head bob movement. When we start sprinting, it becomes more intense. We stop sprinting and it goes back to the softer head bob, and we stop moving and it stops. And that is how we add head bobbing into our game. Since we're going to be working on our inventory soon, we should import a font that isn't UE4's default Roboto text. So first I'll show you how to access the Windows 10 default fonts. So I'll go to my control panel, click here, type in control panel, and we have to find appearance and personalization. So if I click control panel right here, appearance and personalization, then we could just click on fonts, and here we have all the Windows default fonts. You can also easily download your own font or create your own, but if you just want to have access to all those default fonts you see, this is where you'll find them. I'm just going to use Calibri here as a example. Now, an important thing to note about horror games, a lot of indie developers I've seen make the mistake of putting this creepy, unique font for everything and anything that has text. This is definitely a bad idea, as for simple things on your HUD, you want to be able to read clearly. You can think of any AAA horror game, none of them have like blood dripping texts or creepy wood scratch texts, just as like their subtitles and the way their HUD elements are shown. For that, you just want some kind of normal text. Use a regular font for nearly everything in your game, while stuff like the title can have unique fonts. So in UE4, I'm just going to minimize this for now. We're going to create a new folder called Fonts. Open it up. And I'm going to reopen the control panel, and I'm just going to drag in my Calibri font right here. Minimize that again. Now, when it asks to create a new font asset, click yes for the first one, and it'll pop up again because it's going to ask for every single one, and we're going to click no all for the rest. So it only creates one font asset. So now we have 1, 2, 3, 4, 5, 6 fonts and one font asset. Now these 6 fonts are the different like bold, italics, etc. versions, but we only want one font asset for this, so let's save. Now if you downloaded a font that only has one option, just hit yes for the first one and you'll be totally set. So we can open up the font asset and we can add all the different versions. So we have our default, which is just Calibri, and it shows right here. So we can click add font and we can choose what it's called. Let me click on it first to make sure I can see what it is. And this is Calibri Bold. So I'm going to rename it to Bold. Add another font. I believe the next one's italic. Go on. Yes, it is. Add font. I don't know what the next one is. This seems to be light. So just call it light. Add font. And it's this one, since light italic. Light italic. And is this the last one? 1, 2, 3, 4, 5, 6. Yep. Z. It is, I believe it is bold italic. So I'll just call this bold italic. And I'll hit save. So let's test out what this looks like. So I'm just going to go to our UMG folder and open main HUD. This is just a text test, of course. And we'll add a text block. And under here, under font, we have our default Roboto. And now we can choose Calibri font. We also have Droid Sans Mono and Roboto Tiny, which are also default. But Calibri is now new. We can get Calibri. And now we have 6 different typefaces. Our bold, bold italic, default italic, light, and light italic. Now if in the beginning, when we imported our fonts, if you create a different font asset for each font, we would have had 6 different options in here. The Calibris we list in here. That's not how we wanted it. So we can see right there. I'm just going to messily resize this and bump up the size. And you can see we can now change what kind of text this is. And then, like, since we added this to our main HUD, we can go in the game and just see what it looks like on our screen. So great, now we have our new text option and how to import fonts. I'm just going to delete this from our main HUD, and that'll be it for this episode. Alright, you've made it to section 5. Let's get started on our inventory. We're going to be basing our inventory on the Resident Evil inventory without the inclusion of singular items taking up multiple slots. We'll have the ability to pick up objects and add them to our inventory, stack items, and each item will have the option to use, examine, and or discard. So without further ado, let's get started. Alright, so first we want to set up our layout. So let's go to our UMG folder here, and I'm going to make a new folder inside of this just because we'll have a lot of widgets for our inventory specifically, and we'll call this inventory. And we can open it up. And we have to first make a widget, so user interface, widget blueprint, for one singular inventory slot. So W inventory slot. So we can open that up. Dock it here. Our inventory slot, we don't want to worry about our screen size. So let's change this fill screen to desired on screen. The only difference, I think I mentioned it before, but the only difference between desired and desired on screen is desired on screen shows you the actual bounds of our layout, so you kind of get a sense of how big and small you are making your widget. So that's just why I prefer it. So we can delete the canvas panel, and let's add a size box. The size of this will be the size of one inventory slot. So imagine them in a 4x2 layout, or however many slots you want to have. For starting out, we're just going to have 4 slots horizontally and 2 vertically, so 8 slots. And we're doing this just to kind of see how much space we want it to take up on our screen. And I am going to be going with 120 by 120. So check width and height override, and just make the box 120 by 120. And then have 4x2 of these. I think that'll take up a good amount of space. So let's add a button to our size box. And after that, we need to put an image on top of it. But instead of just adding an image, we're going to add an overlay first, which allows palettes to be stacked on top of each other. And we'll come back to why we're using the overlay later. And we'll just put the image in the overlay. Let's just make the image fill the entire thing, or do that with the overlay, but we can leave the image to fill here as well. And take out the padding, so it just fills the entire thing for now. And then in the button, let's rename it to inventory slot, or let's just do slot button. And we want to make sure it is a variable. And then same with the image, we'll just call this slot image, and also a variable. In the button, we want to search for padding in here. And we can just take this normal and pressed padding to 0 for all of them, just so it doesn't have any padding when we click on it. The default padding is to give the illusion of the button going inwards when we click on it, but for the style of our own button, I don't want that. Next, we want to search for focusable, and we want to toggle is focusable to be off. This is so in the future when we have a complete array of inventory slots. When we press our tab button, which will be used to open and close the inventory, it will know to close the inventory menu rather than register the tab button as trying to select the next button as the currently selected button. So we can close that as well. So let's go into the graph, and we need a variable, and we're going to call this index, and it'll be of type integer. We need a index variable so we know what index each slot is in the full inventory, because it'll be indexes 0 through 7 for our 8 slots. So each one needs a different number in our index. Let's make it editable, and we also want it to be exposed on spawn, so we can check that as well. So that looks good for now. Let's create a new widget. So right click user interface widget blueprint, and we'll call this W inventory grid, and this will be our grid for our slots, and we can open it up. And same thing, we want to change this from fill screen to desired on screen, because we don't have to worry about the entire screen layout. And we can remove our canvas panel. Just delete that. Instead, we want to replace it with a uniform grid panel. So this creates a grid for us. And you can probably guess that this grid will contain the amount of slots we want to have. So let's rename it inventory grid panel, and we want it to be a variable so that we can access it from inside our blueprints. So let's compile and save that, and let's go to our graph. And we have this event pre-construct right here, similar to the construction script in other blueprints. And we want to add a for loop. And this is not a for each loop, sorry, just a regular for loop. And this is where we're going to generate our slots. I'm just going to delete these two right quick. But we don't want to control how many slots we have in this blueprint. We want that stored in our player controller. This way, if we ever want to add or remove slots in game, it will remember how many slots we have as we go from level to level. So let's open up our player controller by going into our game blueprints, and level 1, oh, not level 1, it's right here, HG player controller. And we can create a variable, and we'll call it inventory slots. There we go. Took me a couple tries. And this will be an integer as well. We can compile and save that. I'm going to make the default 8, as we were talking about earlier. We'll compile it again. And we can go back to our grid. So now we have to cast to it. So let's get our player controller. And we can cast to our HG player controller. And we can right click and convert to pure cast, because we don't need to run it through the execution nodes. As the HG player controller, we can get our new variable, inventory slots. And let's subtract 1 from this and plug it into our last index. So -1, or integer minus integer. If you just type in the minus key, it'll come up. And we want to subtract 1 and plug it into our last index. We subtract 1 because the loop starts at 0. So 0 through 7 would be 8 slots. If we left it at 8, this would be 0 through 8, and it would give us 9 different executions to the loop body instead of 8. So that's why we have to subtract 1 from our... So in the loop body, we want to create a widget. And the widget we want to create is our inventory slot. And we now have this input called index, and the reason this is here, right in our create widget, is because in our slot, we made our index variable exposed on spawn. So it comes up right when we spawn in our widget. So we can just plug in the index right into the index. Now all 8 widgets we've created has a different number assigned to them in their index variables 0 through 7. This will be very helpful when we need to add and remove items. We also want to promote the created widget to a variable. So let's do that now. promote to variable, and we can call it slots array. That's because we're going to be changing it to an array. So let's actually just break these links because it's going to complain. And click on this little icon here. Oh, not this one, sorry. Down here, click on this icon and change it to an array by clicking on that little grid. And it'll complain, just hit change variable type, and we won't have any errors. So we can actually just delete this and pull it out again and get the slots array this time. And we need to add to the slots array. So we'll add. So in our array here, every time the for loop is called, which will be 8 times, we add a reference to these slot widgets in a array. So there'll be 8 elements in our slots array after this for loop finishes. Now if we were to just end this here with our inventory slot widgets, and we were to press play with this on the screen, we still wouldn't see anything. No slots would be actually added to our view. And that's because we need to actually add the widgets to our uniform grid panel right here. So let's pull off our inventory grid panel, and we'll do add child to uniform grid. Plug it in right here. And for content, it'll be the return value of our created widget. Now we need to tell it which row and which column it'll be set in. We need to do some math for it to figure out how to add each one into the next section. But let's come back to that. First, let's go into our UMG folder and open up our main HUD. And let's just add our inventory grid to our main HUD. So if we go here to user created, it'll show us the widgets we've created. And here we have inventory grid. And of course, at the moment, it's completely empty. And that's because we actually add the slots in our graph. So it won't happen until we press play into our game. So let's, here on our inventory grid, let's check size to content. So it'll resize based off what's added to it. And we can just leave it on the screen because we'll be removing it in a minute. We don't have to worry about positioning it. So let's hit play. And I can see that white box. That white box is the inventory slot widget. Now it is actually adding 8 of them, like I said, but they've all been added to row 0 and column 0. So they're all stacked on top of each other. So we need to do the math to actually spread them out. So let's go back into the grid. And if we actually take this index here and we plug it into column, compile and save, and we press play, we now have this really long, wide box. Now this isn't actually a really long, wide box. This is all 8 inventory slots set up side by side right next to each other. There's no padding in between each slot, so they're all right next to each other, and it creates the illusion of one long box. And that's because the index is adding a new column for every single one. But this is also not how we want it. I'm just demonstrating that all 8 actually do spawn in. So we want our slots to start on a new row after the 4th one, or at least I do. You can choose whatever number you want, but I want it to be 4 slots and then go to the next row. So let's go back to our inventory grid, and we're going to create a variable, and we're going to call this slots per row. And this will be of type integer, and we don't want it to be an array, so we click this and change it back to a single variable. Now we're putting this variable inside the inventory grid because I don't plan on ever changing this in-game. I'm fine with it being totally static, so I don't have to worry about it being in the player controller. If you want, you could also put it in the player controller if you want it to update mid-game. I'm going to make the default 4, because that's how many I want. So for row here, we want to get our slots per row. Let's pull it out. We'll press get. And we have to get a divide node. But we don't want to get a divide integer by integer. We actually want it float by float. So let's plug this one into the B. It'll convert it automatically. And for A, it'll be our index. out of the output, we want to get a truncate and plug that into our row. A truncate will always round a number towards 0. In other words, a positive number will always round down, and a negative number would always round up. For example, once we're on our third inventory slot, which has an index of 2, we divide 2 by 4, and we get 0.5. This rounds down to 0 through our truncate, letting us know we are still on row 0. Once we reach our 5th slot, that'll have an index of 4 because we subtract 1 to get our index. We want to go to the second row. So 4 divided by 4 equals 1, and truncating that will just give us an output of 1. For our 7th slot, it's pretty self-explanatory now. Index of 6 divided by 4, we get 1.5. That truncates down to 1, and we still are on row 1. So we can freely change the slots per row to how many slots per row we want, and that'll accurately decide what row our slot should be in. Now we need to set the columns correctly, because right now it'll always just keep adding 1 for columns. So we can break that. We need a division node, division, and grab this one, division, whole and remainder. And this gives the option to input a dividend and a divisor. This will return how many times the divisor goes into the dividend. The dividend will be our index, so we'll plug that in. Actually, let's grab it from the conversion to a float. And the divisor will be our slots per row, so we can plug that in like that as well. In other words, we're seeing how many times the number 4 fits into our index. Let's take the 7th slot for an example. It has an index of 6, because the index is always 1 less than the slot number. 4 goes into 6 one time, and gives us a remainder of 2. This means it goes into column 2. I don't want to overcomplicate things, but column 2 is actually the 3rd column, because the columns also start at 0, as we can see. So, let's truncate the remainder, because we need to convert it back to an integer. This isn't actually rounding anything because we're only working with whole numbers. And we'll plug the return value into the column node. So let's compile and save, and let's press play. So as you can see, we have this box. We have the first 4 in separate columns, and then it goes down to the next row, and we start off again at column 0, and it continues in that sense. So the way this is set up, we can go into our player controller and we can set the slots to whatever we want. So if we did like 11, should be 3 rows, and the 3rd row shouldn't be quite full. Yep. So it goes down to the 3rd row and it adds 3 more. And then you can also go into the inventory grid and change the slots per row. So instead of 4, say I wanted 5, and press play. And it now adds 5 at the top, and the next 5 are 6 through 10, and then that last one of the 3rd row is number 11. I'm just going to change this back to 4, and the inventory slots back to 8. Press compile and save. Last thing I want to do is add some space in between each slot so we can see them a little more clearly. Probably should have done that before the demonstration, but I'm pretty sure you got the idea. So let's go into our uniform grid panel, and in slot padding we can just give that a value of 10, so it adds 10 in all directions. So let's hit play, and now you can see we have our padding in between our slots. So let's give the inventory a bit better design. Before we get started, I want to change one thing. When I press play, I don't prefer my viewport to stay inside the selected viewport. I'd rather have it in a new editor window. So if you click on this little arrow right here and hit new editor window, it opens up a 3rd window we can open up. I'd prefer it to fill the entire screen. So if I click this arrow, go into advanced settings, we have here viewport resolution, and we can set this to 1920 by 1080 or whatever your monitor size is. So now I hit play, and it fills my entire monitor. It actually fills slightly more than my monitor, because you can see on the top on the left, there is some borders. And you can see on the right and the bottom, we don't see those borders, and that's because it's slightly overcompensating the size of the monitor. So we actually need to pull back a bit to make it fit the size of the monitor. The values that work on a 1920 by 1080 monitor is you'll actually want to change it to 1910 by 1046. And now if we hit play, you can see these border on the left and the border on the right, border on the top and the border on the bottom. So now it actually fits our screen perfectly. Okay, let's get started into the actual video, which is our inventory design. So first we'll have to import some textures. So we can open our textures folder and hit import. And you'll just have to download the textures from the resource tab. It'll be 4 textures. So just navigate to your textures files and open them. We need to adjust some settings in here, but I don't want to do each 4 manually. So we can right click with all 4 of them selected and go to Asset Actions and bulk edit via property matrix. Now in texture, we just want to change this filter from default to nearest. In compression settings, change this to user interface 2D. And in level of detail, change texture group to UI. Now hit file, save, and we can close that. So let's go back into our inventory slot widget so we can actually adjust the look of the button. So we can hide the overlay so we don't see our image here. And on slot button, under appearance, we have this style, and we have a style for normal, hovered, and pressed. Before we do that, I want to change the background color, and I'm just going to adjust the alpha to 0.6 so you can see it's slightly see-through. Hit OK. So for normal, we just want to search for background normal, which is the one we just imported. This is the black one with a gray outline. And before we continue with the other 3, or the other 2, I mean, let's unhide this and let's change this slot image to our empty icon. And that's just this X shape. So we can compile and save, and we can hit play. And now we have these much better looking icons. And I'm just realizing a quick mistake I made. I'm just going to go ahead and leave the mistake in, show you how to fix it. Let's select all these again, right click, and but what we want to do is bulk edit via property matrix again. This is a change I made that I didn't mean to. In texture group right here, in filter, we changed this to nearest. Mine says multiple values because I was just checking real quick and changed a couple of them. We want to leave it on default. We don't want it on nearest. This changes the texture filtering mode, and the nearest makes them a bit choppier. So if we hit save now and hit play, I don't know if you can tell a difference, but it definitely looks a lot cleaner and a lot smoother. I got them mixed up. So we can close that and we are back on track. All right, they're looking great, but we also need to change the hovered and pressed for our button, because that would look like a very jarring change when you hovered over them and pressed them. So let's just go in here, and I called them background hovered and background pressed for convenience. So we can just change them. Background pressed. There we go. And compile and save. But we can't test what these actually look like until we can use our mouse in our inventory menu. So let's do that. First, let's add an actual inventory menu that we can toggle on and off instead of just temporarily putting it in our main HUD. So let's go to level 1. In our textures folder here, I'm actually going to create a subfolder, and I'm going to call this inventory. because a lot of our textures will be inventory based, and I like to organize. So we'll just select these four, put them into inventory, and we'll leave the crosshair out of it. Okay, now let's go to UMG, inventory, and let's create our third widget. And we'll call this W inventory menu. Open it up, and what we want to do is add our inventory grid. This one we want to leave on fill screen, and we want to leave the canvas panel because this is what we are adding to our screen, and we want to keep a full screen layout. So in user created, let's add our inventory grid. And I want to, instead of sizing the content, I want to resize it to see how much space it'll occupy. So in the size X, we know our inventory slots are 120 by 120. Excuse me. So in our size X, we want to take our 120 and multiply it by 4. 4 being the amount of slots in the X-axis. Then we want to add 4 times 20. This 20 is the padding that we added in our grid because we add 10 on each side. So we have 10 on the left and 10 on the right, which adds up to 20. And we get a value of 560. So with the Y value, we want to do the same thing. And let's account for how many slots may be added in the future. Remember, we put our inventory slots in our HD player controller, so in the future we can pick up, say, a backpack and add more slots later on. But let's say the max amount of slots you could possibly have by the end of the game would be 8 more, so 16. This would make the size Y the same as size X, because right now 8 has 2 rows, so it would be half, but if we double that, it'll be 560 as well, which makes this a perfect square. So let's center this square to the middle. So let's get our anchor, and we'll put it in the center, and we'll set our position X and Y to 0. But once again, if you remember me talking about pivot points in alignments, this obviously aligns to the upper left. We don't want that. We want the pivot point of our inventory grid to the center. So we can take our alignment here, and we can set it to 0.5 and 0.5, and now it is perfectly centered. I also want to add a thin black background for when we open our inventory menu. So let's add a image to the canvas panel. Let's rename it to background and fill it to the screen. So with the anchor, let's choose the fill screen version, and these change to offsets. So the offset left, offset top are 0, and we just have to change the offset right to 0 and the offset bottom to 0, and that fills our entire screen. So let's just change the tint to all the way black, and the opacity to 0.3, so it's a little see-through. Hit OK. And we want to make sure this is always in the back. Right now it's in front of our inventory grid, and we don't want that. So that's where the Z order comes into play, which is the ordering of the widgets based on priority. So we can give this a value of -1, and that'll put it on the bottom, as long as everything else is above -1, which they will be because the default is 0. And I can see our inventory grid is above. Lastly, let's add some text that says inventory. So let's wrap our inventory grid in a vertical box. So right click, wrap with, and let's find vertical box right there. We have a vertical box here, which takes the shape of what we set our grid to be. And our grid is now this tiny little line, and we could just set it to fill. Let's take our vertical box, and let's increase the Y value by 100 to make space. Oops, I set it to 100, meant to add 100, so let's make it 660. To make space for our text, let's add a size box above our grid. Let's put it right there. And we don't have to worry about the width override. The height override, though, will be 100. So now our grid takes up this space, and this size box takes up this space, which is for our text. So we can just add a text to the size box. And we'll come back to this real quick. The inventory grid, it doesn't actually have to be fill. We can set it to auto, and we can align it to the bottom and top. It'll fill in automatically when we add in our slots. As you can see, I accidentally just dragged this whole background for a second, so we'll have to change those offsets all back to 0. And we can lock it if we want, and that way I can't move it or anything. Great, so our inventory grid is now in the top left, and our text box, let's just rename to inventory, do it in all caps. Let's center it, so we can click here and there. We can change the font to our new font. I imported Calibri. Let's make it bold, and let's change the size to maybe something like 34. I could probably go a bit bigger, 38. Yeah, looks good. And then we want to move the shadow offset. It's not perfectly centered. It's kind of hard to tell when it's inside this box, but the shadow offset just offsets it slightly to make room for our shadow, which is also turned off. We don't really need it when we have this black background going on. So if we set the shadow offset to 0, you can see the text just slightly move when I hit 0. So I'm going to hit enter, and you can see the text just slightly move, and that'll perfectly center it. So it looks good for now. So let's compile and save. Now let's go into our project settings, and we need to add an input to open and close our inventory. And we'll just add another action mapping, and we'll call this inventory toggle, and we'll assign it to the tab button. Close that. In our player controller right here, we can add input toggle inventory toggle, and we want to make a custom event for this custom event, and we'll just call this toggle inventory. We have to make it a custom event instead of just putting it all right here, because we have to call the toggle of inventory custom event from other places in the future. So all we have to do is just call that custom event right here on pressed. So let's create a boolean, and we'll call this is paused, and we will make it a type boolean. And let's just create a branch. First we have to ask if we are paused to let us know whether to close or open the inventory. In order to create this widget though, we want to create it in the begin play and just add it and remove it in our toggle inventory custom event. So in begin play, we will create widget, and we will be creating the W inventory menu. That's this one that we just made. And we just want to promote this to a variable, and we'll call it inventory menu ref. I'm going to actually add a W at the beginning there. Compile and save. And then right after here in the beginning, we want to set visibility to collapsed, and then add it to the viewport, so that when it's added to the viewport, we don't actually see it. It won't be visible. All right, so let's go back to our custom event here, and if we are not paused, we want to set is paused to true, and then we want to disable our movement, so we don't want to be able to walk around while we are in the menu. So let's get player character, and I think we could just call disable movement from here. Yes, well, it needs to go through character movement first. So character movement and then disable movement. After that, we want to ignore the look input, which means the camera will not rotate with our mouse as we move it around, because we want it to be static while we can select things in our inventory. So we will set look input, set ignore look input, and we want to set that to true, so it does ignore it. Then we want to set show mouse cursor to true, so our mouse cursor becomes visible. And then we want to make our inventory menu visible, so we will set visibility, and the visibility we want is non-hit testable self only. This is a visible version, that doesn't let us click on it. We will still be able to click on our inventory slots because those are considered separate widgets. After it's opened, we want to set our input mode. So set input mode, game, and UI. Our player controller is ourself, because we're inside our player controller right now. The widget to focus, that's our menu ref. And you can choose whether to lock the mouse. In our viewport, I prefer not to. Okay, so we'll obviously need to revert all of this when we close our menu, but we can actually test it out right now. So we go, hit play. We actually should remove this from our main HUD first. So go into our main HUD and just delete our inventory grid right here. Compile and save. So when we hit play, our inventory widget has actually already been created and added to our screen. It's just invisible. And we can still walk around, still look around. And then if we hit tab, our inventory screen suddenly becomes visible. You've also noticed that our mouse cursor becomes visible as well. And when I move it around, our camera does not move around. Also, pressing the WASD keys does not move us around. We've also focused into our widget, so we can now see that hovering over our buttons and the hover and press work accordingly. Even though we set the entire inventory widget to non-hit testable, these still register our clicks. Hitting tab again won't do anything, so we need to set that to revert everything right now. So we basically just have to do the opposite on this true path. So we'll set is paused to false, and then we need to re-enable movement. There's no just enable movement, it doesn't exist. If I search, see? And that's because we need to set the movement mode. So we'll click that. And we need to set the movement mode to walking. Everything we've added in our current movement system is under the walking movement mode. Then we need to set the ignore lookup input back to false. So we will get a reset ignore look input. This will reset it. We want to hide our mouse cursor. So we'll set show mouse cursor to false. And then we want to hide the inventory menu. So we'll set the visibility to collapsed. And lastly, we want to set the input mode just to game. So set input mode game only. And our player controller is self. Compile and save. And let's test that out. Hit play. If we hit tab, we can't walk around, we can't look around, and we can interact with our inventory. Press tab again, mouse is gone, we can look around again, and we can move around again. Alright, so we now have the ability to open and close our inventory. Great. Let's go ahead and make a structure to hold all our variables for our inventory items. So let's go into Content, Blueprints, and let's make a new folder called Structs. Open it up, and let's make a new struct. So right-click, Blueprints, Structure, and we will call it S for struct item data. So we can open it up, and this will hold all our variables for the data that our inventory items will have. So the first one is the name of the item. So we'll call it item name, and it will be of type name. We also need an item icon, so and we'll call it icon. And this will be of type texture 2D. Texture 2D, object reference. And that's all we need for now. We'll add some more later, but that's everything we need in this moment. So let's go to our inventory slot, and let's add this as a variable. So in our graph, create a variable, and we'll call it S item data, and it will be of type item s item data. We could just call it item data without the s. Compile and save. So now you can see we have the ability to add a name and an icon. We also want to add another variable, and this will be amount, and it'll be the amount of the item that we have in this slot, and it'll be an integer. So compile and save. We are going to make our inventory in another Blueprint component. So in our Blueprints folder, Blueprint component, we can add another one. So I'm going to right click, Blueprint class, and actor component. And we will call this BPC inventory. And we'll attach this to our character later. So back into Blueprints, let's go into actors now, and let's make a new folder, and we're going to call this inventory. And we need to create an actor, and it will be called BP inventory item master. So we need an actor for all our inventory items. So let's open that. And this one needs the variable as well of our S item data. So let's go into variables and create it. And we'll just call it item data. And it'll be of type S item data. Now to demonstrate this, let's make an actual item. This is just the master item, which controls overall code that we need for all the children. But let's make a child now. So right click, create child blueprint class, and we'll replace the master with flashlight battery, which will be one of our inventory items. So open it up, and what we can do is here in this item data, now this is where we want to change the name and the icon. So let's change the name to flashlight battery, and we can choose the icon to we'll just have to choose something temporary for now. Let's go ahead and choose this green face here. I usually use his face when I need temporary icons, just for fun. So let's see if we can add this to our inventory in-game. First, we need our inventory to know what items it has and how many of each. So we need yet another structure called, let's go into structures, blueprints structure, and we'll call it S inventory items. And in here, we'll need two variables. The first one is our inventory items master. So let's make it BP in inventory item master, and it'll be a class reference. And the second is amount. So we'll call it amount, and this will be an integer. Let's call the first one item. I know we're adding a lot of things at once, but I hope it'll all start to clear up soon as you start to understand the function of each one. So back in our BPC, so blueprint component BPC inventory, this is where we need to keep track of what items we have and how much of each with the structure we just created. So let's create a variable. We'll call it inventory slots, and it will be of type S inventory items, which is the structure we just created. And as you can see here, we don't want to set it to anything yet, but we can choose either the master or all the children. Right now we just have the one flashlight battery, and we can set how much we have of each. We want to make it an array so that we can have multiple of each one. So let's see, I can have one of the flashlight battery, and then if there was a second one, we can make it that, and this one has 10, and this one has 2, etc., etc. But let's press the little trash icon there to reset it to 0. So in the begin play, we need to let this know that it should actually have 8 slots. They'll all be empty, but it needs 8 of them. And the reason we're going to do it here instead of just hitting this 8 times is because we want this to dynamically be able to change if we decide to go into our player controller and change how many slots we have. We don't want to have to remember to go in there and then also come here and add more. So in the begin play, let's get our inventory slots, and we're going to get a node called resize. And for the number, we just have to get our player controller, cast to our HG player controller, convert it to a pure cast, get the inventory slots, and set it to that number. Cool. So now our inventory slots variable has the same number of slots we have in our game, and they're all empty. So first off, we want to give us the ability to add an item to our slot. And we'll do that with a function, and we'll call this add item. And we'll give it 2 inputs. And we will call these inputs item and amount. So when we call add item, we can let it know which item do we want to add and how much of that item. So the input will be our BP inventory item master class reference, and the amount will be an integer. Let's make a local variable for both of these. So drag off, promote to local variable, and we'll call this local item. And same thing with the amount, promote to local variable, and we'll call this local amount. Since these variables are local, we can't call them anywhere except inside this function. Double click here to create a reroute node, just to clean it up slightly. So before we add an item, we have to know how much of this item can fit in one stack. Can you only have one in an inventory slot, or can you have up to, say, 16 in one inventory slot? To set this per item, we'll have to add it to our struct. So let's go to blueprints, structs, item data, and we will add a variable, and we'll call this max stack amount, and this will be an integer. Save. Once we add an integer, or any variable, to the struct, if we want to set it in our inventory items, which we added in blueprints actors inventory, we have these inventory items. First we have to open the master, and we have to compile it, and then we can open all the children, and we can set that amount. So for flashlight battery, let's say we can have a max stack amount of 8. Cool, so let's go back into our BPC inventory, and we want to set another local variable. We can create another one. We'll call it local max stack amount. This will be of type integer, and we don't want it in an array, so we'll just click here and make it a single variable. Compile and save. Let's set that right here. And to get the amount based off our item, we can get our local item, and we will get the class defaults. And here in the class defaults, if we go back to our inventory item, I can show you, if we click on this self right here, we have these defaults, and that's where we added our variables. It's essentially the same thing. As you can see, it has all the stuff we already added. So if we get the defaults, it has this one variable. If we add variables, it'll add variables here as well. So we have our item data, and we can break it, and this gives us all our item data. And we can drag off our max stack amount and plug it in right there. Compile and save. So the order we want to go in when trying to add an item. First, we want to check if we already have flashlight batteries in our inventory. And if we do, we want to check if there's a stack with less than 8. Because if there is, we want to add it to that stack. If there is not, we want to add it we want to search for an empty stack, and if there's empty stacks, we want to add it to that. If there's no empty stacks, we cannot add it at all. So we have to create a function called check for empty slot. In check for empty slot, we want to create a for each loop with break, and the array is our inventory slots. So let's get our array element and we'll break it. And we have this item and amount because in inventory slots, it's of type S inventory items, which is our item and amount for our struct. We just basically want to check if the item is valid. So we'll get is valid class, and we'll create a branch for this. Put in our loop body. We want to create a variable, our local variable here. We'll call it local success, and we'll make it a boolean. And if we find a slot or the item is not valid, that means it's empty. So it means we succeeded in our thing. So we will set the local success to true. Did find an item in that slot, we will have our local success be false. If it's true though, we want to immediately stop the for loop so it doesn't set it back to false. So we will drag this off, and that's why we got the for each loop with break, and we will plug it into our break. To make this cleaner, we can double click and add reroute nodes to make it more clear of what's going on. So once this is completed, we want to ask if we succeeded or not. So click here, and we'll add an output of type boolean, and it'll just be success. Plug it into completed, and we will plug in our local success. We also want to know which slot we found that was empty. So we'll have to create another local variable for that. We'll call it local index. This will be of type integer. Compile and save. So if we did find a, if we did successfully find an empty slot, we just want to, we just want to set our local index here, and we can plug it into array index right there and connect that to our reroute node, and then we'll break it. And then we can have another output for index, be of type integer, and we can plug in our local index. So let's go back into our add item now that our check for empty slot is done. So lastly, we just want to make this entire function pure. So if we click on this or this, we can just select this button pure, compile and save, and that just eliminates the need for execution nodes. So if we drag it in somewhere, you can see there's no place to put an execution node in. So in add item, we just want to drag in check for empty slot. So right now we're just checking for an empty slot. We're not going to worry about stacking just yet. So we want to ask if we successfully found an empty slot. So we'll get an if statement, plug it in. And if we did, we just want to set this index as our local index. So we'll promote to local variable, and we'll set local index. And we'll put that in on the true. If we didn't succeed, for now we can just add a print string, and we'll just say this, we'll call this no free slots. And we want to add an output for our add item called success, and it'll be a boolean, and we can just put it right here, and it'll be false. If we did succeed, we want to get our inventory slots. Oops. And we want to get a set array element. This way we can set one of these elements at a specific index. And remember, once we start the game, this will not be 0, it'll be 8, or whatever you have for your inventory slots. So we will set the array element. The index we want to set comes from our local index, or we can just do it like that as well. And the item will be our local item. And we'll have to actually make the S inventory items, which is kind of the same as breaking, but the opposite direction. And the item will plug in here, and the amount will plug in for our local amount. Great, and that's all we need to do for now. Let's bring that down a bit. Just doing a tiny bit of organization, and we'll compile and save. So this will actually work in the sense of our inventory actor retaining the information of what item we have at one slot, and we can actually test that out. So before we forget, let's actually add our BPC inventory to our player. So let's open our L1 character, and let's add a component, BPC inventory, compile and save. And let's give us a way to actually pick up items in our world. So let's go to content, blueprints, actors, inventory, and let's make a new folder. We'll call this pickup actors. So these will be the actors we actually place inside the world and pick up. So let's open that up. And let's create a blueprint class actor, and we will call this BP pickup actor, master. We can open that up. We have a lot of things open right now. We can add a static mesh. This will be the mesh that we actually look at when we pick them up, and we'll just add a cube for the master. And then we need a sphere overlap. So create a sphere collision. And let's make the radius something like 100. This cube, I believe, is pretty big. It's just, yeah, that's huge. So let's change the scale down to like 0.2 maybe. And see how that looks much better in our world. So we need to add two variables in our pickup actor. One will be what item this is. So it'll just be called item. And it will be of type BP master inventory item master class reference. Not the pickup actor, that's herself. And amount. And this will be how much this specific pickup actor is holding. We have integer. We also want to make the amount editable. So now we just want to add the ability to pick up the item when we overlap this sphere, which will just be a placeholder way of picking items up. So let's click on the sphere collision, scroll down here, and we want to add on component begin overlap. For the other actor, we want to cast to L1 character. So this way it'll only, after this part, will only trigger if it's our character overlapping with the sphere, not anything else. We want to get our inventory from our character, so get BPC inventory. So we can create a reference to our blueprint component inventory and access the variables. And we want to call add item, which is the function we created. Plug it in. So now we are adding the item, and that's why we have our item variable and our amount variable. Now, if this was a success, if we did successfully add it to our inventory, we want to destroy the actor, which is ourself. And if it was false, we don't want to destroy the actor because we didn't successfully pick it up. We didn't have the room, so we want to leave the item in the world. So let's make an actual item we can pick up and not just the master item. So let's delete that from our world. And we'll right click and we'll create a child blueprint class. And we'll replace this master with flashlight battery. And we can open that up. For the static mesh, I made a small mesh in Blender that you can feel free to use, and definitely feel free to replace if you'd like. So if you want to import that, we can go into content. We can add a new folder called props. And inside props, we can add 2 folders for both materials and meshes. And in mesh, we can import the battery mesh, which I provided in the resource folder. So let's just open that. We do not want it to be a skeletal mesh. Auto-generate collision is fine. Transform can all stay the same. And we can go ahead and create new materials. And we'll hit import. So it has 2 materials. It's something very simple. I just whipped up in Blender real quick to kind of look like a battery. So we have something to use other than just a cube. It's definitely something you'll want to replace and not use for a final product. So we can close that, and we can move. Let's save these first. And then we can move these to the materials folder that we created in our props folder. Okay. Okay, so let's go back into our pickup actor flashlight battery. Don't go into the master one. And the static mesh, we can just change to the battery. Okay, can't really see it because of the default scene root. It has that sphere, but it's right there. Compile and save. And then for our item, we have to set this to flashlight battery, so it knows that's the one to add. And then the amount, by default, can just be 1. Okay, compile and save. So if we place it into our world, let's go into blueprints, actors, inventory, pickup actors, flashlight. You can see we made the amount variable editable, so we can actually change how many batteries this specific pickup actor will hold. Let's leave it at 1 for now. Now we can see the battery over there. I'm just realizing now it is tiny, and I'm not sure why. Oh, I remember why. It's because our master pickup actor, if we go to review port, I changed this cube to be 0.2, which makes this also 0.2. Since I don't want to have to remember to change this to 1 each time, I'm just going to change this static mesh back to 1. It will be huge, but we're not ever putting the master item into the world, so we don't have to worry about it. So back in here, the battery should be full-sized. And in the worlds, yeah, battery is full-sized. So if we overlap with the invisible sphere around it, it should be able to add it to our inventory, because our inventory is completely empty. So if we go over, nothing happened. Let me figure out why. Okay, I've figured out our problem. It's because if we go into the blueprint component inventory, and we have this return node success, I forgot to add it on the true node where it actually adds it. So let's copy the return node and paste another one right here. In this one, we want the success to be true. Then we compile and save. So it actually was adding the item to our inventory, but if we go into our master item, we only destroy the actor if the success was true. So we never set the success to be true, so it just stopped right here, and it didn't know to destroy the actor, but it did technically add our item. But now it'll look more the part, because when we walk over our battery, it'll be destroyed. Now it is technically in our inventory now. Our BPC inventory knows that it added it to the first empty slot it found, which is our first slot. We have not set it to our widget, so we don't see anything here. These are not correlated at the moment, it's just design. But we have no way to see our inventory, so we can see this with a debug. And then we'll wrap this episode up because it's getting a little long. So in our L1 character, in our debug section here, we can just add a input 1. So when we hit the 1 key, we just want to get our BPC inventory, and we want to get our inventory slots variable, and we'll just get a for each loop for all of them. And in the loop body, we just want to print a string, and we can break this, and we just want to know which item is where and how much. So we want to, if the item is valid, we want to get a select from the string with the it's valid in the index. If it is not valid, we will just say no item, and if it is valid, we want to get both the item and the amount. And we can do that with an append node, which can add multiple things. First, we want to plug in the item, which will get the display name. And then we just want to create a colon and a space. And then we can add another pin, and it'll just be the amount. So let's compile and save. So if we go in and we press 1, we have 8 no items, which correlate to these 8 as well. They're all empty. No items. Now if we go here and add this item, remember it adds a flashlight battery, and the amount is 1. So on the very first index, which will be at the bottom, because it goes bottom to top, we can see if we hit 1, it says BP inventory item flashlight battery 1. I'll hit it again so you can see. So now our inventory actually knows and remembers where our items are in the inventory. And we can actually change the amount. So say this battery is actually equivalent to adding 4 batteries to our inventory. We go over, and if we hit 1, if you look at the end, it now says 4 instead of 1. Great. Now we don't have any way for it, obviously, to add more to stacks. So if we were to like duplicate this and have this one be like 3, it will always find the next empty stack. So if we pick up this, oops, I hit escape instead of 1. If we pick up this first one and hit 1, we have added 4 batteries, and we pick this one. See, it takes up the next 2 slots. They don't add them together. It also doesn't account for our max stack amount yet, which is 8. So if we put this something above 8, like 10, it'll still just add 10 to our inventory slot. See how it says 10. So we have some work to do, but we've made some huge steps in this episode. Hopefully you were able to keep up, and I'm excited to expand on it in the next one. So it's great that we can now add items to our inventory, but let's make it so we can view it in our inventory widget. Because as I showed you last time, even though we are adding it by pressing 1, it does not show up in our widget. So in the BPC inventory, actually, let's clean this up a bit. Give me 1 second. Okay, much better. So let's open up our BPC inventory. So if you go to Blueprints, Blueprint Components, BPC Inventory, we need a new function, and this will be called Get Item Data at Index. So it needs an input called index. Oops. And it'll be of type integer. The point of this function here is to get, obviously, as the name of it describes, the item data based off a certain index of our inventory slots. So we want to basically just get our inventory slots, find a slot at this index, and get the data from that slot. So let's create 2 outputs. And it'll be the item and the amount, which is the data we are looking for. Amount will be integer, item will be inventory, BP inventory item master class reference. So let's pull that over. Let's get our inventory slots here, and we will get a copy, and we will get it from the index of our input. So now this outputs an array element at this index. So we just need to break it and plug in our item to our item and our amount to our amount. So pretty simple function here. Let's also make the function pure so we don't have to run the execution node, and compile and save. So we need another function, and we're going to call this update inventory slot. And this is for updating the inventory slot widget so we can actually see the name and the icon, etc. So let's add input for index of type integer, so we know which index slot to update. And we want to get the player controller, and we want to cast to HD player controller. Right click, convert to pure cast, and we want to get that inventory menu reference we made in the begin play. If you don't remember, we can go into our game PB, HD player controller, and go to begin play, and when we created our menu ref, we created our widget, we created a reference. So we want to get that reference. And from our inventory menu, we want to get the inventory grid. So in our inventory menu, we have our inventory grid inside here. And since it is a variable, we can access it from this inventory menu ref. So we'll get inventory grid. And from our grid, we want to get our slots array. Now, if you don't remember, we created our slots array when we generated each inventory slot. We added it to this variable slots array. I'm just going to open this up too. So we have each inventory slot. We create one a certain amount of times. For us, it's 8 based on the player controller, and we add it to this variable. So from this slots array, we want to get a copy to choose which slot we want to update, and the index will come from this index. Now from this, we want to call a function to update the slot, but we have not created that function yet, so we'll have to do it now. So if we go into our W inventory slot, then our graph, we can create a function, and we'll call this update slot. And just so before we forget, we can go back into our inventory and we can just call it right now. Update slot, and plug it in. We're getting an error. That's just because we didn't compile this first. So we just compile that and then compile this, and it's all fixed. So let's add this to our add item function, because every time we add an item, we want to update the slot. So obviously we only want to update it if we successfully added it to our inventory. So let's just put this right after setting the array element. And the index will be our local index that we set right here for checking for the empty slot. So now when we pick up an item and we successfully add it to our inventory, the widget will be updated as well. So let's actually do something with our update slot in our W inventory slot. And in this slot, we need to call BPC inventories get item data at index. So to do that, in our event graph, let's create a custom event, and we'll call this initialize. And in it, we just need to cast to the L1 character, get player character, and we just create a reference by promoting this to a variable, and we'll call it player ref. So in update slot, we can now grab our player ref, and we'll get our BPC inventory. And in that, we have our function get item data index. There are no execution nodes because we made it pure. The index input will be our variable index that we set in our inventory grid. Remember, this index goes right in here, so they all have a unique index. And for now, the only thing we can update is the icon. Change it from an empty icon to whatever icon is set per item. So we want to get the slot image, and we want to set brush from texture. Plug it in. And we'll just get class defaults from our item again. We can either break this or split the struct pin. Essentially does the same thing. And here we have our item data icon, and we can plug that into texture. We also want to check match size, and that way no matter what the size the icon is, it will scale to fit the size of our image right here, which we have set to 120 by 120. We need to call our initialize function for all of our slots in our inventory menu. So on construct, we can create a for loop. That'll be a for each loop, and it'll come from our inventory grid slots array, which is all our slots that were created. And in our loop body, we just want to call our initialize function. So all of our slots inside our grid get initialized. So now we can test to see if it works. So we'll hit play. All of these should have been initialized now, which just means they have our player reference set. And when we pick up an item, now when I open my menu, the first icon should change to that little green face, which it has. It also knows that the name is flashlight battery and stuff. We just don't have any current way to show that. Pick up these batteries. The second one should also turn to the green face. Great. Let's create another pickup actor and inventory item to make sure it works with multiple items. So let's go into content, blueprints, actors, inventory, and let's duplicate the BP inventory item flashlight battery. And instead of flashlight battery, we'll call this door key. And we can open it up, and we could just change the data. We'll call it door key. The icon, we can give it this little red one here if we want, and max stack amount. I don't know, do 16, or let's do 1. We also need a pickup actor for the door key. So in pickup actors, we can duplicate this one, and we'll just call it door key. And let's open the full blueprint editor into viewport. And for now, we could just make this a sphere. Let's see, editor sphere? No, it's way too big. Sphere. Can do this one maybe. It's also pretty big. There we go. And we'll just have to change the item to door key, and the amount, we'll leave it at 1. Come out and save. And let's just delete this second flashlight. We could keep it there. We'll just add in our door key here. And now let's test it out, see if we can add a second item. So let's grab our flashlight battery, and we've added our flashlight battery to our inventory. And let's grab our door key, and now we have a door key. So we can now add multiple items to our inventory. A key part of this episode will be deciding which items can be stacked and which can't. We already added our variable inside our struct, if we can find that, blueprints, structs, item data, for max stack amount. And then, if you remember, we refreshed our master item and opened up our one item that we have. Let's find that real quick. It's in actors, inventory. Right, we have 2 items now. I forgot we made another one last episode. And we set the max stack amount. For flashlight battery, we set it to 8. And door key, we set it to 1. Setting it to 1 will be the equivalent of not being able to stack items in our game. So let's go to our W inventory slot. If you remember, that's in content, UMG, inventory, W inventory slot. In fact, I'm gonna start closing some of these. I'll close the controller. I'll leave these 3 open, and I'll close all of these for now. And here, this is where this overlay comes into play. If you remember, last time I said we had to put it instead of just putting the image. And this is because we need to add some text letting us know how many items we are currently holding. So let's go ahead and add a canvas panel to our overlay, and let's make sure it fills the entire thing. And then we want to add a text block to the bottom right. Oops, let's add that inside the canvas panel. And we want to add this to the bottom right of our icon. But first, let's wrap this with a size box so we can directly control the size a little easier. So let's right click, wrap with size box, and that puts a size box as a parent of our text block. And our size box, let's make it 30 by 15. And we're going to anchor it to the bottom right. So let's set our position X and Y to 0. And this will put it on the wrong side, but like always with the alignment, instead of making it 0.5 by 0.5, we want it on this corner now. So it'll be an X value of 1 and a Y value of 1. And now it's inside our canvas panel. I'm also going to offset this by 5 so it kind of stays inside this gray area of the entire icon. So let's grab the size box and let's add 5 or -5 and -5. So let's select our text now and let's type in 0 for the text just by default. We can change the font to our new font, Calibri, and I think I'll make it maybe light, and let's bring the size down to 10. Let's align it to the right side and then the center of that. So that way, as the number increases, it goes to the left. So if we keep adding zeros, you can see it now goes to the left. See? Let's change that back to 0 by default. We can also turn off the shadow offset so it centers itself a bit better. And we can compile and save, and we can press play to make sure it looks good. If we hit tab, and we have that 0. I think I might offset it just slightly more so it's not quite as close to the gray. So let's grab our size box, and let's make this something like -7, I'd say. -7. Okay, let's test that again, and I think that looks better. Or maybe like -6. I don't know, it's completely up to you. The fun part is just to tweak and make it look like something you want. Perfect. So let's grab our text here and let's make it a variable. So let's call it amount text and make it a variable. And we want the default visibility to be hidden. And let's update this in our update slot event. So we can just go up here to our update slot, and after we update our slot image, we can get our amount text, and then we want to set the text, so set text, and we'll get this number from the get item data at index. We just take this amount and we'll plug it in there, and it will automatically change it from integer to text. And we can open this up to mess with the details. First, we can toggle whether we want to use grouping, and grouping is adding commas for larger numbers. So if we go over 1,000, if we do select use grouping, it'll add a comma after before the first 3 zeros, and if it's off, there will be no commas. The minimum integral digits, this is the minimum digits that the number can have. So if it's 2, and say our amount is like 5, instead of writing 5, it would write 0, 5, because it would have a minimum amount of digits to 2 instead of 1. But I'm going to leave this at 1. So we can close that and compile and save. So after this, we want it to make the amount text visible if we have more than 1. If we have just 1, I don't want the text to show up, so we can just get a set visibility, and the target will be our amount text. We'll just plug it in from there, and we can get a select node from this. And the index here is just if this amount is greater than 1. Plug it into the index. If that's true, we'll have it visible, and if it's false, we'll have it hidden. Compile and save. So we can actually test out if this works. So let's hit play, and here we have our battery. We pick it up, and we have 10 batteries. If you remember, click right here. the amount is set to 10, and here the amount is set to 1. So we pick up our 10 batteries, and we have 10, and we pick up our 1 door key, and there is no number because we don't show a number if it's 1 or less. But we also need to add ability for stacking. As you can see, I just picked up the other battery, but it adds it over here instead of adding it on top of this one. Well, this one would have to go to 8 and then 2 because the maximum stack is 8, but we'll fix both of those things. So let's go into our BPC inventory, and in add item, I'm just going to scroll out here. We just want to check if the max stack amount is greater than 1. And if it isn't, we just want to do all of our old code here. If you can only pick up 1, we just want to check for an empty slot because there's no reason to check for stacking. So we can just pull this down, create a new if statement, and we can check if max stack amount is greater than 1. And we'll put that in condition, and that's if this is false, we want to continue to just finding free stacks. There's one more thing we'll have to add to this path to avoid a bug, but we'll come back to it. On the true path, we need a function to search for a stack with room. So let's create a function called check for free slot. We just want to check for a slot that has room. So for example, the flashlight battery, if it has a stack that is less than 8, because 8 is the max stack amount. So let's create an input, and it'll be of type item. It'll just be our BP master inventory item master class reference. And we just want to add a for each loop with break for the inventory slots, because we want to first see if we can find the item that we're looking for, and then we'll check if it has room in it. So we can break the array element, and we just have to check if the item is equal to our item input. Create a reroute node. Then we want to add an and, because we want to make sure it also has room. And we want to check if the amount is less than the max stack amount. So the item, we have to get the class defaults, and we can split this and make sure our amount is less than our max stack amount, and we'll plug that into the second condition of the and. We want to have 2 local variables, local success, which is a boolean, and local index. And this is an integer. And let's create a, oops, didn't mean to open that. Let's create a if statement and plug that into the condition for the branch. And on true, if we do find it, we want to set local success to true. And on false, we want to set a local success to false. If we did succeed, we want to set the local index to the index that we found. So we'll plug this index into the array index, and then we want to break the loop. So just add reroute nodes to make it more clear of what's going on. And then on completed, we just need 2 outputs. So let's select here. And the outputs we have, I'm just asking if it was a success, type boolean, and what our index is of type integer. Plug that into completed, and we can just plug in our local variables for these 2. So let's add this to our add item function. So if the max stack amount is greater than 1, we want to check to see if we have a free slot. Plug that in. And the item we're checking is our local item right here. We want to ask if it's a success. So we'll ask if success. Because if it isn't, we want to look for a empty slot instead of just giving up. And if it was a success, we want to add it to that slot. So if it's false, we just want to copy this check for empty slot, and we'll ask an if statement off that. And if this was false, if we weren't able to find a free slot or an empty slot, we'll have to add a return node, with the success being false. Let's add a second output to our return node. So we type integer, and this will be called remainder. And we need a remainder output just in case we can pick up some of the items. So we go here, see how this is amount is 10. Let's say our inventory is completely full except for the last slot, which has 4 batteries in it. We pick these up. We want to be able to pick up 4 out of the 10 batteries to fill the last slot, but keep the remaining 6 on the floor. So we need to know what our remainder is, which would be 6 in this example. On this path, however, the remainder would be the entire amount because we were not able to find a free slot or an empty slot. So we'll just plug in our local amount to the remainder. And since our return node changed for these two, for this one we also want to add local amount for our remainder, because we were checking for a free slot and we did not find one, so we don't pick up anything, so our entire amount will be our remainder. And on the true path, where we do add it to an empty slot, our remainder would be 0. So off the true path here, we want to set our local index. We want to update it to this new local index, because if it's true, we want to add it to an empty slot. And then we have to check if the amount is greater than the max stack amount. Because if the amount is less than the max stack amount, we don't have to worry and we can just add all of the items to the new empty slot. But if it's more than the max stack amount, we kind of have to call this whole thing again after adding in the max stack amount, for example 8, and then saying if you had like 2 left over, you have to call this again and then recheck for a free slot, recheck for an empty slot. If you find one, you can add those 2 to that one, and if not, they are left on the ground. So let's just get our local amount, and let's ask if it's greater than our max stack amount. And if it is, and since this is going to branch off again, we can pull this down just a bit more. If it is, we only need to add the local max stack amount to the inventory slot, and not the local amount. So let's do the easier path first, which is false, if our local amount is not greater than, because then we can just add the entire local amount. So we'll set an array element. The target array is our inventory slots. Index is local index, which has now been updated to this empty slot. The item, we can split this and we can plug in our local item and our local amount. After that, we just want to update the inventory slot, add our local index, and then we'll call a return node, and success will be true and our remainder will be 0. Now off the true path, oops, let's fix that real quick. We want to set the array element, and inventory slots will be our target array. Our index, once again, be our local index. And for item, oops, I promoted that to a variable. Did not mean to do that. Can delete it. Split the struct bin. The item will be our local item, but the amount will be our max stack amount. And then we will update the inventory slot. I'll just copy and paste this right here. And then after that, we want to call our add item function again with the remainder of our local amount. So we'll call add item, and our item will still be our local item, but the amount will be our local amount minus the max stack amount. And then we will call a return node, and we want to check success, because this specific index of adding the full max stack amount was a success, and the remainder we want to plug in from our add item. So let's go back to one of our first branches here. And what if we did find a free slot? All of this was only if we didn't find any free slots. Now we need to know what to do if we did. So if we did, we want to set, or we can just drag it in, we want to set our local index to this new index that we just found. And we need to add our amount, our local amount, to this slot with the item already in it, or our free slot. So let's get the item data at index from the local index. And we want to add this amount to our local amount. Oops. And we're not actually setting this to be our local amount, because that wouldn't make any sense. We're just doing this to check and see if it's over the max stack amount or not. For example, if we do find a free slot, and it has, say, 4 batteries in it, and we pick up 8 batteries, we need to check to see if 4 plus 8 is greater than our max stack amount, which is 8. So 12, which is the local amount, plus this amount, is greater than the max stack amount. So if it is, we only need to add the first 4 to this slot, and then with the remainder, we want to call this again to check for a free slot and check for an empty slot. So let's ask if the result of the added amounts is greater than the max stack amount. Let's create an if statement right here. And we can start pulling things down again. Just create some room. And if it isn't greater than the max stack amount, then that's perfect. We can just add the amount and we're done. So let's do that first. So off the false pin, let's set the array element. And we want inventory slots, local index, split the struct pin here, get the local item, and the item amount will be this added amount here. We want to get the amount we already had plus the local amount. After that, let's update our inventory slot. I can just copy and paste this one right here. And add a return node with success checked, and the remainder is 0. If the amount is over the max amount, however, we need to do something different. So let's set the local amount to the added amount. Oh, I'm sorry, not just this. We want to set it to the added amount here minus the max stack amount. So let's set that array element. We can just copy and paste this right here. And we just want the local max stack amount for the item amount. So this fills up the free slot that we found. And then our new local amount is that amount minus this amount. And then our new local amount is these two added together, but with this subtracted from it. So let's update our inventory slot. And we want to recall the add item with our leftover amounts. So let's call add item. And local item for item. And local amount for amount. And this is our new local amount after we've done this math here. So let's call a return node. And we want to check success because adding this local max stack amount was successful. And our remainder will come from our remainder in add item. Cool, that should all be set up. Now let's fix that small bug I mentioned earlier in the path for non-stackable items. So just to go from the beginning, we set all our local variables, and we ask if the max stack amount is greater than 1, and if it's not, if it can't be stacked, we ask if it checks for an empty slot. And instead of adding our local amount, we only want to add 1. So we can actually delete this. And the bug that I was talking about is essentially if you have this item with the it's our door key. If you remember, we set our door key to have a max stack amount of 1, so it can't be stacked. If we were to set this amount to something higher, like 3, we'd want this to disperse across 3 inventory slots. With the way we had it, with if this had just been local amount, it would have defied the max stack amount number and would have just added 3 to one slot. So instead, we only want to add 1. So after we update the inventory slot, we want to subtract 1 from our local amount. So we'll get local amount and we'll subtract 1. And then we just have to check if this is greater than 0. And if it is, if we still have items, so for this item specifically, we would have picked up 1, and then we would have subtracted the amount, so it would have become 2. And is that above 0? Yes. So if it is, we want to recall the add item function, so it can just go through all of this again. And if it's not, we just want to stop it. We just want to pick up our item and be done. So we'll just ask if this is greater than 0. Put that into a branch. And if that is false, we just want to call a return node with success being true and a remainder of 0. But if it's true, we want to call add item, and it'll be our local item. And the new amount will be our local amount minus 1. Great. And let's create one more return node. And the success will be successful, and remainder will go into remainder. Our add item function is fully set up. I hope you were able to follow along with it because it gets pretty complicated, but I did my best to explain everything as thoroughly as I could so you could understand kind of how this branches out and how it works and how it decides where to place each item. There's one last thing we should do before we test it, is to make sure not to destroy the pickup actor if we can't pick it up. So if our inventory is full and we can't pick it up, we don't want to destroy this actor. So we have to go to our pickup actor. So it's in inventory, pickup actors, master. And, oh, I forgot we already put the branch in. I guess in my notes I did it in a slightly different order. But we also want to update the amount that this pickup actor is holding after we call the add item, and that's why we have this remainder output. Say if your inventory is almost full, but you have room for 1 of, say, these 10 batteries, and it picks up 1, we want to update this so it changes to 9. So if we did pick it up, which means this true path goes, we need to check if we picked all of it up or just some of it. So we can just create another if statement here, and we can just ask if the remainder is greater than 0. And if that's true, we don't want to destroy the actor. We do if it's false. If it's not greater than 0, it means we picked up the entire thing and our item is gone. We destroyed it. If it's true, though, we just want to take our amount variable and we want to set it to the remainder of our add item. And we can compile and save. Alright, time to test our code. Let's make, let's move this over here. And let's make 3 of these flashlight batteries. Let's give the first 3, and the second one 4, and this one 5. And let's get this door key, and let's keep that at 3. So let's test this out. So obviously when open our inventory, it's empty. So when we pick up our first actor, which is 3 flashlight batteries, it won't find a slot that already has batteries. So it'll put it in the first empty slot it finds, which is our first slot. So let's pick it up. And we can see this now has a little number 3. We have 3 batteries right here. Now, when we pick up these, we have 4 batteries. It will search again for a slot that has batteries, and this time it'll find it. Our first slot does have batteries in it, so it'll add these 4 to our slot. And now it says 7. Now we have 5 batteries left, but our max stack size is 8. So what it should do is add 1 to our slot that it finds, and then the next 4 to the next empty slot. So let's pick that up and see if it works. And there we go. We have 8 here and 4 in the next slot. Now for the 3 door keys, these are unstackable, so when we pick them up, they should take up the next 3 slots. And they do. Great, so let's bump up our door keys to something like 9. And remember, we only have 8 inventory slots, so we don't have enough slots to hold 9 door keys. So when we go up to it, the actor won't disappear. And it'll say no free slots because that's a debug we added a long time ago. And now when we open our inventory, it's filled up the first 8 slots, or all 8 slots, with door keys. This amount here has changed to 1. There's only 1 door key on the floor now, instead of 8. Great. And I guess last thing we can test is very similar to the one we already did, but if we change this to something like 10, and pick it up, it should put 8 in here and 2 in there. So it's able to do it even if it starts at a free slot. Alright, so now we are able to add multiple items in every single way. I'll see you in the next one, where we work on disabling empty inventory slots. So to disable the slots that don't have anything in them, we don't want kind of this hovering effect to happen if there's nothing in the slots, or at least I don't. We can go into W inventory slot, and in update slot, in the beginning, we just have to add a branch. And the condition, we can already use this existing get item data at index, pull it out, and ask if the item is valid. Plug that in. If it's true, let's let's get the slot button here, and let's set is enabled. And check that to true. And if it's false, we can just set is enabled to false. And we also want to make sure we set the icon. So we get our slot image and set brush from texture to our empty icon. So we can just right here, empty icon, and let's check match size. So it stays in the 120 by 120. Let's also make sure in our event graph, in initialize, we call our update slot function. Oh, and one last thing, in the update slot, after we set our slot image, just to be safe, we want to get our amount text and set the visibility to hidden. So compile and save, and we can just test it out. We can no longer hover over any of these. We can grab some items, these become available, and these are still not. And that'll take up the rest of our slots here, and they're all available. Alright, that'll be it for this one. In the next one, we'll start working on the drop-down menu, which will soon give us the ability to use, examine, and drop items. We need to create a widget that contains our use, examine, and discard buttons. To do this, we have to create another widget. So let's go into our UMG folder, inventory, and let's create a new widget blueprint. And we'll call this W inventory dropdown. So we can open it up. And we're going to put in a size box. And we're going to make it 120 by 120. Oops, 120 by 120. And this is the size of our inventory slot. We are doing this just so we can make the size of our drop-down menu in correlation of the slot size. So this will be deleted soon, it's just for reference. So we can add another size box. And with this one, we can try to drag it out a bit, and you can just kind of resize it and choose, see how big you want the drop-down menu to be. I'm going to go with something like 240 by 120. And this will hold the 3 buttons for use, examine, and drop. So we can delete this original size box, and we can delete the canvas panel. That gets rid of our other size box as well. So we'll have to add it back in. And we want this to be desired on screen. And let's just make this size box 240 by 120, which was the size I chose. And let's add a vertical box to this size box. And in that vertical box, we need 3 more size boxes. So I'm going to make the height override 60. I'm sorry, not 60, 40, which is a third of our height. And we can copy and paste this 2 more times and make sure all 3 are in the vertical box here, not children of each other. And we need to add buttons to all of these. So let's get buttons, and we can copy and paste into here. Now we don't want these regular button textures. I made some new ones for this, so we can go ahead and import those now. So let's go into our content, textures, inventory, and we can import. And I'm just going to go into my resources file, and I have a drop-down button and a drop-down button hovered. We can open that up, and we can right-click, and we need to asset actions, bulk edit via property metrics, and we need to change the sometimes I have trouble knowing where they are because when you open them individually, it's in a different order, so sometimes I forget. Compression, and change the compression settings to user interface 2D, and level of detail texture group is UI, and file and save. We also want to go to texture and set filter to nearest, and this will sharpen up our image a bit. So we can close that. So let's go back into our W inventory dropdown, and we have our buttons here, and we can start renaming them. So we can call this use button. This one here will be the examine button, and this one here will be the drop button. And we'll take this use button here, we'll take the normal, and we'll just search for button. Oops. And we have drop down button. That's the normal, and we can draw as image. And then we can take the hovered, oops, take the hovered and search drop down button hovered, and as image. And for pressed, I'm just going to use the hovered again, and image, and then I'm just going to tint this a little darker. Okay, compile and save. And instead of doing that all again, I'm actually just going to delete the examine button and delete the drop button, and then just copy and paste these in here, and then we can just rename them. Alright. We also want these size boxes to be variables because we need to choose whether we want this entire button to show or not, depending on what item can do what. So we'll rename these size boxes to use size box, and check is variable, or we'll call it use section, and then we'll call this examine section is variable, and drop section is variable. So let's add some text to our use button, and we'll just type in use. So let's change the font to our Calibri font, maybe bold. Size can be something slightly smaller, like 20. Make the padding to full, and then justification to center. And we can get rid of the shadow offset. And we could just duplicate this on the other ones, and we'll just rename this to examine. Let's do this in all caps, and drop. So to test what this looks like in game, we can add it to our inventory menu. So I already have it open, W inventory menu, and let's just go into user created here, and let's get our W inventory drop down, just put it in anywhere. And let's make sure it's above our background. And well, I guess it doesn't matter because we set our background Z order to -1. And so as long as this is 0 or something higher than 0, it'll always be above. So we're fine on that. And let's just test this out real quick. So we hit play, and it's over here on the left, and you can see we can now hover and click on all of them. And of course they won't do anything, but this is just to test what they look like. So to move on, we need a inventory menu reference in our inventory slot, which I also already have open. So we can go to the graph. We're going to just go to event graph here. And we can just set this in our initialize function. So we can do it by adding an input to our initialize. And we'll call this inventory menu. Or meant to make that a capital M. And this will be of type W inventory menu object reference. And we can just promote it to a variable. And we will call it W inventory menu ref. And we can just set it before we call update slot. Hold down Control to move this. And just like that. Compile and save. And then in our inventory menu, on the construct, we now have this new input under initialize, and we can just use a reference to self to plug in there. So in inventory menu, let's make a new custom event, and we'll call it open drop down menu. First thing we'll do is make sure the position is correct when you click on a slot. So in our game, I'll wait for that to load because I didn't hit compile, so it has to compile first. When you click on a slot, we wanted to open underneath the slot. So we'll get an input for the open drop-down menu, and it'll be, we'll call it slot, and it'll be of type W inventory slot object reference. And what we're going to do is, depending on the slot, we're going to add 120 for each row and column, which is the size of our slots. So we'll just kind of move this over here. We can imagine it's right here, and then we click on, if we click on the first one, we click on the second one, we'll add 120, so it's kind of underneath that one instead. So if we're adding 120 to each slot, we need to first set its starting position. So let's anchor this to the center, just like our vertical box here. And we want to set the correct position right in this little corner here, where the inventory grid is. For me, that is -160. Oh, I forgot to change the alignment first. First, we want to change the alignment to 0.5 and 0.5, so it's in the center. So if these were to be set to 0, it's perfectly center. And then you have to adjust to make it in the top left there. So what you could do is you could just kind of drag it and till you see it kind of snap where it is, and then you can adjust to see how it's perfectly in line now. And you can do the same for the top. So I already know this is 160, and then the top looks like it could be something like 170. Oops. And I already knew it was, but you can see it is perfectly lined up now. So now we can take our slot input from open drop-down menu, and we need to get this slot as a uniform grid slot, which will give us the row and the column number. So we can get the row, and we can get the column. So we want to add 120 for each column and row index in the respective direction. But we also have to remember the indexes here start at 0. So if we were to multiply this number by 120, it would all be off because the first would be 0 and it wouldn't move at all. So we need to add 1 to both of these. Oops, I cannot hit my plus button. There we go. After that, we want to multiply our slot size, which is 120, or multiply by our slot size, sorry, which is 120 for both X and Y. To get that, we can, out of our slot, we can call get desired size. This way, we don't have to hard code in, say, like just typing in 120 like this, because then if you ever wanted to change the size, it would screw it all up. So this way we can get the size right from this node. So we can break this, break vector 2D, and we just need to multiply the x by the column and the y by the row. So let's move that one above, just for organization purposes. And we can just get an integer times integer, plug in x to there, automatically creates a truncate for us, which is fine. And let's do the same right here. And it'll create a truncate below that. And then after this, we just need to set the inventory drop-down menu position. So we'll do that by set render translation, and we'll plug the execution node right into there. And we will make a vector 2D from this. It's just the same as breaking, but the opposite direction. And we will just plug in, make sure we're doing it right, yeah, this one into the X, and this one into the Y. So now we just need to call this custom event when we click on a slot. So if we go back to W inventory slots, we need to go to our inventory button, which is up here, and we just need to create an onReleased right there. Now with our new inventory reference variable, we can call open drop-down menu, and the slot will be ourself. So now we can test this out. So let's hit play, and we can't pick anything up until we have items in our inventory, because they're disabled otherwise. So by default, this is up in the top left. We don't even want it visible at first, but we'll get to that later. If we click on the first one, it updates our position to be in this lower right section, and it'll do so for all of these. As you can see, the farther we move right, the closer to the center this becomes. And the reason for that is we are not accounting for the padding in between the two slots. We're only multiplying by 120. Same reason why it's kind of in the corner here, because there is also a little bit of padding to the left. So we need to fix that as well. So let's go back into our menu, and in our open drop-down menu custom event, we need to account for the padding. So to get the padding, we can get our inventory grid, which is just the variable for our grid right here, which holds all our slots. And we need to get inventory grid panel, which is the uniform grid panel inside of it, and get the slot padding. Now just to refresh your memory, if we go into W inventory grid, and this is the grid where all our slots are generated, we just gave it a default slot padding right here of 10. So if you are to go in here and adjust this padding, it'll also be updated for our open drop-down menu. So we want to break the margin, and we have our left, top, right, and bottom. I'm going to wait for this autosave, okay. And we want to add the left and right together, and the top and bottom together, because we don't need those as separate floats. And before these truncates right here, we can just add these to our desired size, so they are accounted for. So for the X, we want to add in the left and the right, and for the Y, we want to add in the top and bottom. So kind of move these out just a bit to organize. That's the thing about blueprints. It's great for visual learners. It's bad for getting really messy and becoming spaghetti code. So let's test it out now. So let's hit play. And obviously it's still kind of in the top left right there when we started out. Let's fill up our inventory. And let's click here. And it now perfectly aligns with every single one of our slots. As you can see, there's no offset on any of the slots. And it's super easy to adjust. Say I want the menu directly under the slot instead of under and to the right, if you see right here. We can just go into the menu, And we can change this +1 to the column to a 0. So it offsets it all by 1 for the columns. And if we click on it now, it's directly below it instead of offset to the right. So it looks better, but another tweak we could add is adding 10 after we do our multiplication and subtract 10 on the y. And the reason I'm saying this is because you can see there's this space right here, and there's also this space right here, and I feel like it'll look better if it's just a bit tighter, just right below it. So I already kind of fiddled with it and found that 10 works well for me. So after the multiplications, for the x value, we can just add 10, and for the y value, we can add -10. Compile and save, and if we take a look at it now, it's right up, pressed up against it. And I think that looks pretty great. So let's add one more thing before we wrap up this video. We want the drop-down menu collapsed by default, so we can't see it when we just open our menu, so let's change that. So at the end of our open drop-down menu, let's just change the visibility. We'll set visibility to non-hit testable self-only. So non-hit testable makes it visible, but it makes it so it doesn't register our clicks. Now this can be kind of misleading at first, because obviously we want it to register our clicks because it has buttons, but this is just for the self widget only. And if we click on the top here in our W inventory dropdown and we search for visibility, you can see the default is non-hit testable self only. You definitely don't want to make it self and all children, because then none of it will register, just self only. So this is, we're setting it to be visible once this open drop-down menu is called. But we want it to be collapsed by default. And the easiest way to do that is just in our inventory menu, we can just grab the widget right here, search for visibility, and set it to collapsed. If you don't remember, the difference between collapsed and hidden is not visible but occupies layout space, and collapsed is not visible and it takes no space in the layout. Let me just double check. Okay, couldn't remember if I said it or not. So we want it collapsed. So now when we hit play and we open our menu, we can see it is not there. We can collect some things, still not there, and it only shows up once we click on an inventory item. So I also want it so when we click anywhere that isn't a button in our menu, for it to close again. So for example, if I just click it, and then if I click anywhere in this space that isn't like one of these, I just want the this to go away. And we're going to do that with a giant invisible button. So in our inventory menu, you can scroll out a bit. We can just add a big old button, drag it into here. We'll anchor it to full, and we'll just set all the offsets to 0. And let's put it above the background, and we'll rename it Close Drop Down Menu Button. Now we want to make sure this is below the drop down menu, but above everything else. So to do that, let's change this Z order to 1. Remember, everything else is 0 by default, and then the inventory drop-down menu to 2. So from order from top to bottom, it's our inventory drop-down menu, our giant close drop-down menu button, everything else, and then the background. So let's, we also obviously want to make this visible, so let's take the color and opacity, and let's set the alpha to 0. And let's also do it with the background color. And then we want to set its default visibility to collapsed. Oops, collapsed. We don't want to be able to interact with it normally. We only want it to become interactable once our drop-down menu opens, so we can close it again. So in the graph, at the end of our custom event for open drop-down menu, we want to set the visibility for our button to visible. So we can now click it. And we need a new custom event. And this one will be called close drop down menu. Yep, I spelled that wrong. Menu. In this custom event, we want to set the drop down menu and the button visibility to collapsed. So let's get both of those. Set visibility to collapsed. And same with this. And this is obviously so once we close the drop-down menu, these, both the actual physical drop-down menu disappears, and so does our button, so we cannot continue to interact with it until it is reopened. So on pressing the button on close drop-down menu, you can scroll down, click on pressed. We just want to call this custom event, close drop-down menu. Now, while we have the button open, we want to constantly be setting the focus to the close drop-down menu button, because we'll be losing focus to it as we click on other buttons. So we need to do this with an event tick. That's not what I meant to call. See event tick. And we can just call set user focus. And the target is our close drop-down menu button. For player controller, we'll just get player controller. If you don't do this, sometimes you'll have to click twice in order to close the drop-down menu. Because one will be to focus onto the drop-down menu, and then the second will be actually registering pressing the button. So we can test it out now. Let's grab some items here. And the button is collapsed right now, the giant invisible button. If we click around, nothing happens. And if we open our item, this button has now become active, and it is above everything except these buttons. We can still interact with these. But if we click somewhere else, the menu is now gone. And we can now interact with these again, because it closed the button as well. So let's give some functionality to that first button we have, the use button. Not every item can be used. Sometimes we want to have an item that we just need in our inventory to progress parts of the story, but there's not actually anything we can do by clicking the use button. So we need to add a boolean to decide whether it can per item. So let's go to blueprints, instructs, and sitem data, and we need to add a boolean, and we'll call it can be used. We want the default to be true, because I feel like more items will be able to be used than not. And to test this out, I want to be able to use our flashlight battery, but not our door key. So let's go into our blueprints, actors, inventory, and we'll have to open the master item to compile it. Close it again. And we can open our flashlight, and can be used as checked because we made that the default. But in door key, let's uncheck it, so we cannot use it. So let's go to our W inventory dropdown widget, and in the construct, we need to cast to our player to get a reference. So cast to L1 character. Object is get player character, and we will promote this to a variable. We'll call this player ref. And we need a custom event. And delete these two things. And we'll call this custom event update menu, because we need to update whether we have which buttons we have out of these three. So we'll just get the input slot. It'll be of type W inventory slot, since this is a per item basis. and we will get the slots index, and we need to promote the index to a variable. And we'll just call it slot index. Next, we can just get the player reference and get the BPC inventory. And we can call our function that we made item get item data at index. And the index will be our slot index. It's the same thing as just plugging it in right from here. And we want to get the class defaults from the item. And we can break this. And we have this boolean can be used. So we can, the reason we made the size boxes variables is so we can just hide the whole section instead of having to worry about hiding the button and the text and anything else you might want to put inside the section. So we'll just get the use section, and we will get a set visibility, plug that in, and we'll just use a select node, and can be used will be the index. If we can use it, we want it to be non-hit testable, because we don't want the we want it to be self only, not self and all children, because if it was self and all children, we wouldn't be able to hit the button. And if we cannot use it, we want it to be collapsed. This is a great example of when to use collapsed versus hidden. If we were to set it to hidden, it would become invisible, but it would not delete the layout space that it's taking up. As you can see, if we toggle the eyeball right here, that changes it to collapsed, and we can see how these go up to the top. If it was invisible, we would just suddenly not be able to see it. If I toggle the, oh no, that doesn't work. Oh well. It would suddenly become invisible, but there would still be this space here, and we don't want that space there. So let's go back to our W inventory menu, and in our open drop-down menu, custom event at the end here. Before we set the visibility, just because we have to do more updates, I'm just going to take this W inventory drop-down, and I'm going to plug it in like that. I'm going to have to break the link to the first one, just to clean it up a bit. And before we set it to visible, we just want to update the menu. And the slot will be the slot from our custom event input. So compile and save. And we can now test if it works. So for these flashlight batteries, they can be used to set to true. I'm going to pick them up. And for these door keys, they're set to false. Pick some of those up. So when we click on our flashlight battery, our use is still there. Now if we click on our door key, the use is gone. It is only examine and drop. And that's exactly what we want. Alright, so we got it working whether it should show up or not. Now for when it does show up, we want to actually be able to do something with that button. So we need to open our BP inventory item master. And we need to make a custom event, and we'll call this use item. And that's all we need to do there. And we can open our flashlight battery and open full blueprint editor. And we can now call the use item event. So event use item. And we can print a string, and we can say that in this one we've used a battery. So this is great because after this use item event in any one of our inventory items, this is where we choose what that specific item does. There's one thing I forgot. In our inventory drop-down menu, we need to get all our buttons here, these three, and we need to scroll down and set is focusable to false. This way we'll still be able to click them when we open our menu, since in our inventory menu, when we set the user focus to the close drop-down menu button, this will allow us to continue to be able to press the buttons. So now we can press these, and we can still click off. Alright, so let's plug in our use item event in our BPC inventory, which I still have open, but let's navigate toward it anyway. So content, blueprints, blueprint components, and BPC inventory. So in our BPC inventory, we need to make a function, and we'll call it use item as well. And we need an input type integer, and it is our index. And we'll create a local variable from this. We'll call this local index. And then we can just drag in our get item data at index, and this will be our index. And then we can get actor of class. And from this return value, we can call the use item event. And this way we'll be able to just call use item from BPC inventory, and it'll find our correct item and run through that specific event. But this actually currently won't work because our actual inventory items are not spawned into our world, so get actor of class will return none. So instead of dragging and dropping each inventory item into the world, because it's tedious, so we might forget to do it as we add new inventory items, let's have our code do that for us. So after get actor of class, we should ask if it's valid. So it is valid, and we'll get the macro, plug that into our execution. And if it is valid, we can just continue to the use item. If not, we want to spawn it into the world. And this is a great way of doing it because it'll make sure it'll only spawn everything once. So we can spawn actor from class. And the class we want is this item that we're getting the data from. And for spawn transform, we can just right click and split it, and that'll set everything to 0. So it'll spawn it right in the center of our world. And there's nothing physical in our inventory items because they're not the same as the pickup actors. So there's nothing to physically interact with when they are spawned. After that, we can call use item again. It's the same as this one. And that's all we need to do for now. So let's go back into our inventory dropdown, click on our button, scroll down, and we want a on released. And with the player refs BPC inventory, we can call the use item function. Now the function we're calling here is the one from our BPC inventory, not to be confused with the use item that are specific to each inventory item. So we're calling this function. And the index is our slot index, and that's why we made it a variable in the update menu. So now we can actually test it out. Before we do, let me just run you through the path real quick because it might have gotten it kind of confusing. So we click on this use button, and with our player ref, it calls the use item function at the correct slot index. So it knows which index we are clicking on, and it transfers that to our use item function. In our use item function, we get the data at that index, so we can figure out what item it is with this function we made already. And we just get the item, and we do some extra code here, and we call the use item event. And the use item event is something that we can change for each item. So in our flashlight battery, all it does is call use battery, and if our door key actually could be used, we could add something for this as well. So like event use item, we could print a string, and we'll just call it used battery. To test it, we can actually just select this can be used, and we'll say the door key can be used for now. Oh, I just realized I typed used battery here. We want it to say used door key. So we can test it out. And we could pick these up. I can click here, and if I hit use, it prints the string, use battery, and then all the stamina. Don't worry about that. And then with door key, we now see used, because we set the can be used boolean to true, and it says use door key. Use battery, use door key. Great. So in these events is where you'll set everything you want for how to use certain items. Eventually, we'll replace this use battery string with actually giving our flashlight more power in the future. Lastly, after we use the item, we need to remove that item from our inventory. So in our BPC inventory, we can add a function. We'll call it remove item. And we need an input of the index, so it knows which item to remove. And we just need to call get item data at index. And we need to ask if the amount is greater than 1. If that's false, so if it's not greater than 1, if there's only 1 left, we can set the array element. Inventory slots is target array. Our index is our index. Could make a local variable for this, but it's up to you. And then we can split the item data, and we'll leave this blank. And we want this to become null because there was only 1 left, and we removed the last one. If the amount is greater than 1, though, and we only want to remove 1 from it, we can, once again, set the array element, copy and paste, with the index as the index. Our item is the same as our item data here. And the amount is this amount minus 1. After both these paths, we want to update the inventory slot. So we can just drag that in. And the index from the index, we probably should have made a local variable just to clean things up, but it gets the same job done. And then we could go back into use item, this one right here. And in the beginning, we can just check that the amount is greater than 0 to make sure we can actually remove something. And at the end, we can just call remove item from both. And we can just do it like that. I also want the drop-down menu to close when we use an item. So in the begin play of our BPC inventory, we just, after we cast to this player controller, we just want to get the reference to our inventory menu. Because if you remember, we set a reference to this widget in our player controller, and we can just set this as a variable in here as well. So we'll call it w inventory menu ref, and then at the end of use item, after we remove an item, we can just call the event close drop down menu. So it'll close once we use the item. So we can test that out by hitting play. Let's grab some items and see how it says 8 right here. Once we use an item, it should say flashlight battery used or whatever we put at the top left. And it removed one. We are now at 7. We can continue to use. And now that we have 1 left, it completely removes our item. We can no longer interact with this slot. It's become disabled, and the item has been set to null. Works the same with these battery door keys here. I'm sorry, even though we need to set the door keys back to cannot be used. And every time we click use, the drop-down menu has disappeared, and so has the invisible giant button. Great. And that is how we set up the use button. We'll obviously be coming back to this a bit in the future so we can actually add some use functionality to our flashlight instead of just printing a string. And in our door key, let's just go ahead and check can be used back to false. Our player's backpack is only so spacious, we need to give the player the option to discard items. We will be skipping the examine item option for now, just because it's a bit more complicated than dropping. So we're going to go to dropping and then we'll come back to examining. You might not want to be able to discard every item, however, as some may be essential to your game. So we need to add another boolean to our struct. So go to blueprints, structs, item data, and we can add a new boolean. We'll ask can be dropped. And we'll make the default to true. So in the BPC inventory, we want to create a new function for drop item. As always, we'll add a input for the index so we know which slot we are talking about. And we can create a local variable, call it local index. And then we want to get the item data at this index. We can also create a local variable for the amount, local amount. And then we could just check if the amount is greater than 0. To make sure we actually have something to drop. If I could plug this in, there we go. So if this is true, if we do have something we can drop, we want to create a for loop. Just a regular for loop. And the last index will be the local amount minus 1. And the reason we're subtracting 1 is because the first index starts at 0. In the for loop body, we can call our remove item function with the index as the local index. On completed, we want to close the drop-down menu, so we'll just get our inventory menu ref and close drop-down menu. And let's just call this function in our inventory drop-down menu widget. So when we click on the drop button, this one right here, we're going to create an onReleased. And we can just copy this player ref BPC inventory and call drop item. And the index will be our slot index. So now, if we press play and we pick up some items, and we can click here and we can hit drop, and it just completely removes our items. It incinerates them into nothing. They don't come back into our world, they're gone forever. If you want to spawn the items back in the world when you do this, you do it here in the drop item function. If you want the items to be gone forever, though, similar to Resident Evil, you are already done with the episode. But for the people who want their items to spawn back in the world, we need to add another variable to the item data called pickup actor. So we can go into our struct item data, and let's add a variable, and this will be called our pickup actor. And this will be of type PP pickup actor master, and we want it to be a class reference. I'm also going to use these arrows just to move it up a little bit, just for organization purposes. So let's close that, and we need to once again go to our blueprints, actors, inventory, and compile our master. And then back in these two, we can open them up, and here we have a pickup actor, and we need to set it to the correct pickup actor that we have. So we have a pickup actor for flashlight battery, and in our door key, we have pickup actor for door key. Back in BPC inventory, we want to call a line trace by channel and then spawn the actor after we close the drop-down menu. The reason we're calling a line trace is because if we wanted to drop the actor about 300 units ahead of us, we'd probably be fine if we were looking somewhere like this. But if we were looking directly at the wall here, it would spawn, without the line trace, it would spawn 300 units ahead of us on the other side of this wall. We don't want that, so we cast a line trace, and instead it would spawn right where it's hitting the wall, and it would fall to the ground right there. So in our, right after here, we can just call a line trace by channel, and then we want to call a spawn actor from class. For which actor we're using, we'll get it from the item here. So let's just make a local variable for that as well. Oops, I made that a regular variable. Just delete that. Call this local class. And here in spawn actor, we're just gonna do the spawn actor first, and then we'll do the line trace. We'll get our local class, and we need to, this is not the item we want to spawn, because we want to spawn the pickup actor, not the actual inventory item. So we will get class defaults, and then we will break this, and now we have our new pickup actor variable. We can close that again. Now for where we want to spawn it, this is where we use our line trace, and to do this we need a reference to our character. So here in our begin play, let's actually take this up, create a custom event called initialize, as we've done with many of our blueprints. Plug that into here, and we can just break this from resize. Now me compiling gives us errors, and that just comes from our drop item because it doesn't know where to spawn this. We can ignore that for now because we'll be fixing it later. We need a reference to our player character, and after all this we can cast to L1 character and get player character from our object and promote this to a variable. We'll call it player ref. And then in our begin play, we can just call initialize. And these errors we're getting are just the same ones in our drop item. But now we have our player ref. We can get that. We can get our camera. Should be at the bottom. And we will get the camera's world location. That'll be the start. The end will be to get the forward vector, and we will multiply this by a float. This will be the length of how far you want it to spawn in front of you. I'll just go with 200, and we add these two together, and that goes into our end. And then we need to break the out hit result. So pull that out a bit. We can break this. And we also want to split the transform. And for the location, we need a select node. And the condition is the return value from our line trace. So basically we're asking if our line trace actually hit something or if it didn't. If it didn't, we just want to get the end of this line trace, which should be out in the open world because it didn't hit anything. We get this by just getting the trace end. If we did hit something, however, we don't want to use the trace end. We want to use just this location of where it hit. So we can actually test this out now. So we can pick these all up, and if we're looking out into open space and drop these, it has now been dropped into open space, which is great. And if we're kind of looking up against a wall and drop them, they spawn being pushed up against the wall. Now the other thing we want to set is we want to make sure we are dropping, when the pickup actor is spawned back in the world, we want it to have the same amount that we're dropping from our slot. So just have these have 6. If we drop these, we want to make sure those there have 6. If we pick them back up, it's only 1. We want to make sure they have 6. And this is very easy. We can just go into our PPC inventory. After we spawn the actor, we can just set the amount from our actor to our local amount. And that's why we created a local variable from this. So we can compile and save. We can actually print a string of the amount to make sure. Hit play. Can pick all of these up, And these have 3, so let's drop these. And we see 3 up there. And we pick it back up, and it gives us 3 again. Drop these, 8. Drop these, 1. 1. And we are good. If you want the items to fall when they drop, after this print string, or we can delete the print string, after we set this amount, we can just get the static mesh from here. Scroll all the way down, get static mesh, and we can just set simulating physics to be true. We hit play, and we can pick these up and drop them again, and now it falls to the ground. Now there's a couple problems with this. One is our sphere is not connected to our static mesh. If you see, if we make our sphere collision, if we make it visible, so if we search hidden in game, if we make that false, we can now see the spheres in game. So let's pick this up and let's drop it, and you can see the mesh is falling and the sphere stays the same, and we don't want that. And the fix for this is in the pickup actor master. We just have to make the sphere a child of the static mesh. You just have to be careful that you're not resizing your static mesh. The scale right here is all 1, because if you do, say it's like 0.2 or something, it sizes the sphere with it, and we don't want that. So now when we hit play and we pick that up and we drop it again, the sphere now falls with it. And I'll just demonstrate with physics against the wall as well. And of course, if you wanted, you could go into your pickup actor master, and you could set this static mesh simulate physics to true by default. That way, these will all fall to the ground, and you can pick them up and drop them, and they just have simulating physics by default. Alright, that'll be it for this episode. In the next one, we will be improving the way we pick up items so it isn't just a overlap event.